So in preparation for looking at ways of finding the zeros of third order polynomials or higher, we need to know how to do polynomial and synthetic division. So I think the next section will actually do ways to find the zeros of polynomials. But anyway, this is something you probably have already done, but we're going to review just so you're ready. So there's two ways: long division and synthetic division. Now, long division you can use all the time. Synthetic division, there's some restrictions. But a lot of times synthetic division is is quicker and more compact in the actual carrying out. Long division, like I said, works for any polynomial division. So basically what we're going to do here is we want to take some kind of polynomial. Let's say it's third order. And we want to divide that by some factor of some sort and see what the result is. So one way you can think of it is I'm creating a rational function, and then I'm simplifying the rational function. Now if I divide this polynomial by this factor and I get a zero remainder, then I know that this factor is one of the factors. This denominator is one of the factors of the polynomial. If the remainder is not zero, there's still some usefulness with that. So here's an example. We probably could do this. Well, we could factor this, and maybe this is one of the factors, we don't know yet. So the numerator goes here, the denominator goes there. It's pretty much like normal division, so I'm just going to show you how to do long division with just numbers. So if I said, what I'm doing here is taking 24 divided by 4, which the answer is 6, but the way you would do this is you'd say, what number do I multiply by 4 to get 24? And you say, okay, well 6, my multiplication tables, remember 6 times 4 is 24, so you multiply 6 times 4, and then you subtract that, and you get 0. So the answer is 6, and the remainder is 0. Now if I said, what's 26 divided by 4? You'd say, okay, what number can I multiply by 4 to get 26 or the next smallest number? Let's say integer. And the answer would still be 6. 6 times 4 is 24. And I subtract that, and I get 26 minus 24 is 2. So the answer, 26 divided by 4, is equal to 6 with a remainder of 2. Over here, it was 6 with a remainder of 0. So instead of just getting a number up here, we're going to have a polynomial. And the remainder, instead of just being a number, it will be a number, but the remainder will be a number. If it's not 0, it'll be some number divided by the original denominator. Okay, so same question we asked over here. What do I need to multiply by x plus 3 to get 2x squared plus 10x plus 12? Well, what we're worried about is the highest order term here. And this is the highest order term. So the question is really, what do I multiply x by to get 2x squared? Well, the answer is 2x. Is that right? 2x times x is 2x squared. So you carry out the multiplication, but you do both parts of this. So 2x times x is 2x squared. 2x times 3 is 6x, so I say plus 6x. And just like with long arithmetic division, I subtract. Here I multiplied 6 times 4, got 24, then subtracted it. So the same thing is here. And the whole idea is that these will go to 0 when I take 2x squared and subtract 2x squared. I get 0x squared. And then I go to the x column. 10x minus a positive 6 is going to be 10 minus 6, which is 4. So I'll get plus 4x. And then I'm going to bring down this term. I didn't initially have to worry about it because there were only 2 terms here, which this one term multiplied by these 2 terms gives you 2 terms. So I bring this down now, so I get plus 12. And then you ask the question again, what do I need to multiply x by to get 4x? Well, the answer is 4, so I put plus 4 up here. 4 times x is 4x. 4 times 3 is 12. I subtract that. Again, I subtract in the appropriate columns. Or I add a negative, add the additive inverse, either way you want to think about it. So 4x minus 4x is 0x. 12 minus 12 is 0. So in this case, I have a remainder of 0. So what I can say, one way to say this is 2x squared plus 10x plus 12 divided by x plus 3 is equal to 2x plus 4 with a remainder of 0. Or you can say that x plus 3 is a factor of the original expression. You can also, because this is without a 0 remainder, we can also say that 2x plus 4 is a factor. And if that's true, then if I multiply these things together, 2x plus 4 times x plus 3, using FOIL, I'll get 2x times x, which is 2x squared. 2x, so outer 2x times 3 is plus 6x. 4 times x is 4x. And then I multiply the last, which is 4 times 3, which is 12. Put this on one page. Won't let me move this thing. Just trying to have room at the end to plus 12. And then combine like terms, so you get 2x squared plus 10x plus 12, which is the original number. Okay, so that was easy because it was just second order polynomial, gave us a 0 remainder. So here's a little more difficult one. So again, I'm dividing by x plus 2. I don't have to just divide by, I don't have to have it just a linear term here. I could have x squared, so we'll get to that. But the whole idea of this section is to find factors which are not typically are linear terms. Okay, so got everything's in here. Got x to the 4th, x cubed, x squared, x constant. So the question is, what do I need to multiply x by to get x cubed? I mean x to the 4th. So the answer is x cubed. So I put that up there. Again, I'm just worrying about the 2 highest order terms. This times that equals that. Now I carry out the multiplication. So x cubed times x is x to the 4th. X cubed times 2, 2x cubed. I subtract those 2. So x to the 4th minus x to the 4th, 0x to the 4th. 5x cubed minus 2x cubed is 3x cubed. Bring down the next term. Okay. Now we say, since this, we can just basically get rid of that. So we say, what do we need to multiply x by to get 3x cubed? The answer is 3x squared. So 3x squared times x is plus 3x cubed. 3x squared times 2 is 6x squared. Let's subtract that. So again, these go to 0. In this case, they all go to 0, so you end up with 0x cubed plus 0x squared. So when I go to the next part, something times x equals 0, well, the answer is going to be 0, so plus 0x. Then I bring down both of those, because I don't have anything to do, so I have negative x minus 12. So next I do, I say, okay, what do I need to multiply x by to get negative x? Well, the answer is negative 1. So negative 1 times x is negative x. Negative 1 times 2 is negative 2. And I subtract that. So negative x plus x is 0, so I get 0x there. Negative 12 plus 2 is negative 10. So in this case, I do not have a remainder. So what I can say is x to the 4th plus 5x cubed plus 6x squared minus x minus 12 divided by x plus 2 equals x cubed plus 3x squared, and this should be not raised, should be raised to 1 power, plus 0x minus 1, and then we take the remainder, negative 10 minus 10 divided by x plus 2. So because the remainder is not 0, this is not a factor of that, and the actual division results in this. So hopefully I did that right. So let me just do a quick check here. Yeah, it looks right. Okay, now in this case, the numerator of the fraction had every term, x to the 4th, x cubed, x squared, x constant. Sometimes we don't have one of these, and it doesn't mean that anything's wrong, it's just we don't have it. So if I started out with something like this, which is, two things are different. One is this is not x plus or minus some number, and this, the x cubed is not there and the x is there, and that's because they have 0 value. So you have to reflect that. You always have to have every term in, even if the term is not the original polynomial. If it is missing, then you put a 0 out in front. Okay, so let's work through this one. So again, what do I need to multiply x squared by to get x to the 4th? Well, the answer would be x squared, and I put it in the same column as the x squared underneath, because there's a space for each thing. So I multiply x squared by x squared, I get x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 3 is plus 3x squared. I subtract that, and this one goes out. Then I have 0 minus a negative 2. Well, minus a negative 2 is positive 2. And here I have 3 minus a negative 3, which is 0. Okay. So I'm going to bring this one down, which is still 0. So I really only had that term in the next one. So I said, what do I need to multiply x squared by to get 2x cubed? The answer is 2x. So 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. And 2x times 3 is plus 6x. You got to subtract that. These cancel out, go to 0. Here I have 0 minus a negative 4. Here I have 0 minus a positive 6. And I get that. Then I bring down the last number. What do I need to multiply x squared to get 4x squared? So the answer is 4. 4 times x squared is 4x squared. 4 times negative 2x is negative 8x. 4 times 3 is 12 plus 12. I subtract that. Again, these go out. That's the whole purpose of choosing those numbers. Then you have negative 6x minus a negative 8x, which is negative 6 plus 8, so you get positive 2x. And here we have 1 minus 12, which is negative 11. And we've finished. We can't go any further. So again, this is not a factor of that. And we can take the original, what this division is representing, which is x to the 4th plus 3x squared plus 1 divided by x squared minus 2x plus 3, and that is equal to x squared plus 2x plus 4, and our remainder is 2x minus 1, so plus 2x minus 1 divided by the original denominator. Now, one thing you'll notice, anytime you do this polynomial division like this, the highest order term in the numerator is at least as big as the highest order exponent in the denominator. This will be x to the 4th divided by x squared. And the remainder will always have this as the denominator. So this is the remainder. Well, actually, that's the remainder. But if you actually do the calculation, that's what you get. Okay, so that is long polynomial division. Now, if the denominator in the rational function, or the thing we're dividing by, is x minus plus or minus something, then we can use synthetic division. And see, let's go back, actually use synthetic division on this one. So again, you should have had this already. And the reason you can do synthetic division is because I've got x plus 2. If I had 3x plus 2, I couldn't use synthetic division. If I had x squared plus 5, I couldn't do it. It has to be x by itself. And the way you do it is you draw this kind of upside down bracket thing, and you write the coefficients associated with each term in order of their exponent. So these have to be ordered correctly. You divide by not 2, but by negative 2. So this number here is not the factor, but if I were to set the factor equal to 0, I would get the 0. So I use negative 2 here instead. Okay, so you bring the first number down. Then you multiply negative 2 times 1, which gives you negative 2. You add these two together. 5 plus negative 2 is 3. Then you take negative 2 times 3, which is negative 6. Negative 6 plus 6 is 0. Negative 2 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 2 times negative 1 is positive 2. Negative 12 plus 2 is negative 10. Okay, so now the way you translate this is, we're going to have, because we're dividing by x here, the result is x cubed. So this is the coefficient in front of x cubed. So we have 1 times x cubed plus 3 times x squared plus 0 times x minus 1 times, that's the constant. And then the remainder is this last number, and is negative 10 divided by x plus 2, the original factor here. And you can see that's what we had. We had x cubed plus 3x squared plus 0x minus 1. And then we had as a remainder negative 10. Negative 10 divided by that. So that's how that works. Can't use synthetic division here. So when we look at this, the way we had, if we do long division, we'd set it up as this: 3x cubed minus 17x squared plus 15x minus 25, and we'd have x minus 5 here. But when we do synthetic division, we still use the same coefficients: 3, negative 17, 15, negative 25, but this number is not negative 5, it's positive 5, and that's because we're taking this and setting it equal to 0 and solving for x. Okay, so bring the 3 down. 5 times 3 is 15. Negative 17 plus 15 is negative 2. 5 times negative 2 is negative 10. 15 plus a negative 10 is 5. 5 times 5 is 25. Add those together, you get 0. Okay, so the remainder is 0. So one thing we can say is this is a factor of that. We can also say this is the x squared term, this is the x term, this is the constant. So we'll get 3x squared minus 2x plus 5 plus 0 over x minus 5, which is just, we don't have to show that. So what we can do is, if we write it out, 3x cubed minus 17x squared plus 15x minus 25, all divided by x minus 5, that's equal to 3x squared minus 2x plus 5. Or one thing you can say is that the original function, what we do is you could cross multiply, and you could say 3x cubed minus 17x squared plus 15x minus 25, that's going to be equal to 3x squared minus 2x plus 5 times x minus 5. So we've taken a third order polynomial, made it into a second order polynomial times a first order polynomial. Now, once you get to this point, you could use the techniques we learned in section 1 for quadratics to find the factors of this. So once you're down to a second order polynomial, you can use completing the square, you can use factoring by observation, you can use quadratic formula to find if this can be broken up into 2 real factors. If you can't, then you might have 2 imaginary or 2 complex factors. Okay, here's another one. 3x cubed minus 16x squared minus 72, all divided by x minus 6. So again, you don't use negative 6 here, you use positive 6. 3, 16, there is no x term, so we put it 0 there. Negative 72, so those are the coefficients in front of each one. We have 0x, which we don't show because we don't need to. Okay, bring down the 3. 6 times 3 is 18. Negative 16 plus 18 is 2. 6 times 2 is 12. 0 minus 12 is negative 12. 6 times negative 12. Did I do something wrong here? No, we add these things together. I don't know why I subtracted them. So you add them together. That's right, isn't it? Let's go back here. Yeah, we add them together. So add those together, you get 12. 6 times 12 is 72. Again, you got a 0 remainder. So what we can say is that 3x cubed minus 16x squared minus 72 divided by x minus 6 is equal to 3x squared plus 2x plus 12. Or you could say 3x cubed minus 16x squared minus 72 is equal to 3x squared plus 2x plus 12 times x minus 6. Or you could say x minus 6 is a factor of 3x cubed minus 16x squared minus 72, or x equals 6 is a 0 of 3x cubed minus 16x squared minus 72. So there, we said there are different ways of saying the same thing. And it doesn't matter, this doesn't have to be a whole number, this just has to be a 1. So you can't have, again, can't have a factor in front of that. But you could factor out, if this were 2x minus 3, you could factor out a half and just multiply it out here. So, just as long as, like I said, this has to be 1, but it doesn't necessarily need to start out with a 1. Okay, so again, you don't use negative 3/2, you use positive 3/2. You can take the opposite of that, or you set this equal to 0 and solve for x. That's that. We got an x cubed term, an x squared term, no x term, constant term. Bring the 3 down. 3/2 times 3 is going to be 9/2. Okay, this is negative 8/2. 4 is negative 8/2. Negative 8/2 plus 9/2 is positive 1/2. 3/2 times 1/2 is 3/4. You add these two together, you get 3/4. 3/2 times 3/4 would be 9/8. This is 48. So you get 49/8. So the answer to this one does have a remainder. So this divided by that is going to be 3x squared plus 1/2 x plus 3/4 plus 49 over 8 times x minus 3/2, like that. Okay, so that's just examples of this stuff. So where is this used? Well, it's for answering the question, like on the right-hand side. Use synthetic division to show that x is a 0, meaning x equals -4, is a 0 of the third degree polynomial. Use the results to factor the polynomial completely. So what we're going to do is we're going to do synthetic division, find out what the actual resulting second order polynomial is. We should have a remainder of 0. If we don't have a remainder of 0, then it is not a factor or a 0. Okay. So we take the coefficients here, 1, 0, -28, -48. X equals -4. We use -4. If we had x plus 4, which is equivalent, you'd still use -4. So a factor of x plus 4 is the same as x equals -4. We use what the 0 is, not what the factor is. So you bring that down. -4 times 1 is -4. 0 plus -4 is -4. -4 times -4 is positive 16. -28 plus 16 is -12. -4 times -12 is plus 48. 0. So check. That is a 0. This is a factor. What we have left is x squared minus 4x minus 12. So this may be one that we can do by observation, which it is. So it's going to be x. What two numbers multiplied by 12? So what together give us 12? Well, 1 and 12, 2 and 6, 3 and 4. And whose difference is 4? Well, 6 minus 2 is 4. So one's going to be 6, one's going to be 2. I end up with a negative 4, which means I need to put the negative on the bigger one. If it was positive 4, then I would make that positive and that negative. And you can see if I multiply it out, I'll get x squared minus 6x plus 2x, which is negative 4x, and then negative 6 times 2 is negative 12. Okay, so what that means is that the original function is going to be equal to x plus 4. That's the factor associated with the 0. And then I have the two other factors. And if I were to multiply this out, I'd get back here. So we could say the factors of the polynomial are x plus 4, x minus 6, x plus 2. The zeros are x equals negative 4, x equals 6, x equals negative 2, and that's also the x-intercepts. So the zeros are the x-intercepts. Sometimes they're also the solutions that this is, yeah. Now, besides, if we get something that's other than a 0 remainder, it's still useful. What it turns out is that the remainder is the value of the function evaluated at the 0 that we're evaluating. Okay, so what does that mean? So let's do synthetic division here. So the coefficients are 1, negative 14, 8, 20. Divide that by x minus 5, or x equals 5. So we bring that down. 5 times 1 is 5. Negative 14 plus 5 is negative 9. 5 times negative 9 is negative 45. 8 minus 45 is negative 37. 5 times negative 37 is, what is it? Get my calculator out for that. 37 times 5, 185. So that's going to be negative 185 plus 20. So it's going to be negative 165. Obviously, that is not the 0. But if I evaluate the function at x equals 5, I'll get 5 cubed minus 14 times 5 squared plus 8 times 5 plus 20. So this is 125. 5 cubed is 125. The second term is 14 times 25. 14 times 25, just so we get negative 350. 5 times 8 is 40 plus 20. So 125 minus 350 plus 40 plus 20 equals, oh, just entered in my calculator wrong. Okay, should be on negative 165, which it is. So it's kind of interesting. I mean, here all I did was multiplication and subtraction or addition. Here I have to raise powers. So that's one advantage of doing it this way. You don't have to do any, if your calculator didn't have powers, you could do it using synthetic division. The other thing too is that, now I know, a point on this curve. So besides finding that it's not a 0, I also know that there's the coordinates 5, negative 165 that I could plot and give me some additional data to plot. Okay, so that's it.